All right, so last week we looked at graphs of trig functions and we were writing the equations of them. We identified three properties and we called those the midline, the amplitude, and the period. We then used those three properties or criteria from these graphs to ultimately write an equation of a trig function. Now we're going to be doing the opposite. Luckily, we're going to still look at those same three properties. We need to identify the midline and the amplitude and the period of the wave to figure out how long or how short each of these waves are. And so let's just kind of review some of those properties here from this graph in this first slide. And you'll notice on your notes, I gave you giant big slides instead of the tiny itty bitty squares, so you have lots of room to write on. So when we're going to graph this, these are different key properties that will help us, that we would want to identify from the equation first to help us graph it. But I want to look at the picture first so we kind of know what we're looking for. The midline. So the midline of the graph, that shows us basically where the graph is moving. That's the middle of it, and the graph kind of moves above it and then below it, that amplitude amount. And so on this graph, you can kind of look where the midline is right there. That's kind of like the main guideline for drawing this wave. You'll notice that it goes the same distance above this line and the same distance below this line. And the wave just continues oscillating or moving up and down around that line. So you need to determine the midline. That's going to be our starting point for the graph. So like pretend that this red wave isn't there. Let's pretend I had a blank graph. This is how I'd go about drawing it. I ultimately want to be able to trace that, so to speak. First thing I would do is identify the midline. Like, oh, well, y equals -1. This will be from the equation. And again, we'll look at that next. And I'd want to draw in that midline, okay? So when you're graphing one of these waves, you want to get that midline first. That shows you where on the graph you're going to be drawing the waves. The next thing, we need to know like how tall the wave is, like its height or its bottom end. It's, I don't know what the opposite of height is. Shortness? No, because that's like I don't know, the top and bottom. What we're going to do is call that the maximum and the minimum of the wave. Basically, how high does it reach each wave and how low does it go? Where are the crests and where are the troughs? And if we can identify them, like how high or how low they are, we're going to actually draw two more guidelines. Kind of like how I have this dash line in the middle. It's going to be really helpful to have a guideline for the maximum so I know like how tall to make this wave. So I'm going to draw another dashed line there. Again, pretend that there is no wave yet, and we're going to use these as guidelines to kind of frame it out. And also, if I know where the minimum is, where will those troughs be? Where will the bottoms of each waves be? And I'm basically drawing these three guidelines to help me figure out how to draw my wave, how high to make it go and how low to make it go. And so we're going to identify the max and the min. Again, from the equation, then we're going to draw in these guidelines to help us actually graph it. And so the maximum for this one is at 2. The minimum is at -4. And that tells us the basic size of our wave, where it's going to be located and how high or how low it's going to go. The last thing that we need, though, is to determine the period of the wave. Basically, how wide is it? Like to the sides, is it a really long wave or is it a really short wave that's going to kind of go up and down a whole bunch of times? And that's the period. So to determine the period, we essentially had to find the length of one wave. If you remember, that's what the period is. It's a single wavelength from the start of the wave to the end of the wave. Now, for this function right here, can any of you determine if this is a sine wave or a cosine wave? If you remember that activity we did last week, we had to do that often, determine sine wave or cosine wave. What do we look for to determine if it's sine or cosine?
To see if it's on the midline or 0.
Yeah. You check out the y-axis. We're going to view that as like our starting point for our waves. And you can see that the waves, the slopey part of the wave, right? The slanted part, bless you. The slanted part is on that y-axis. So we're starting there. It's kind of like in the middle of the increasing part of the wave. If I were to trace out a single cycle, a single wavelength, starting at the y-axis, I'd start here, I'd move up, down, and end back up. Doesn't it kind of look like a letter S? I know it's kind of backwards and flipped and sideways and all that, but do you kind of see the S familiarity there? That kind of tells you that it's a sine wave, all right? And so it's like a, I don't know, a snake. I think the S could work. And so that's a single sine wave. That's its starting point. This would be its ending point. So you need to trace that out. And once you've got a single wavelength traced out on our graph, what's the period of this wave? How long is it? Just look at the x-axis. Right? If I'm starting at 0, you can see that it goes to pi. And so we need to know what the period is. And basically, once we know what the period is, I know that I've got to draw my wave so that it moves above and below the midline, that it bounces in between the max line and the min line, and that it ends at pi. It's a lot of things you have to kind of keep straight. So the way that we're going to graph this, either a sine wave or a cosine wave, is you're going to want to draw 5 points. I'm going to go through those with you right now. So you need to start with the starting point. This is point number 1. If it's a sine wave, you start on the midline. If it's cosine, you'd start at the maximum. That's point number 1. Now, the end point for a sine wave will also end on the midline, right? Sine wave starts and ends on the midline. So plot those 2 points first, because that kind of shows you that I've got to get an entire sine wave in between these 2 points. So that's where we're going to start and finish. Whatever the period is, you put your final dot there, so to speak. After that, once you've got those 2 points, think of those as endpoints. Now, let's find the middle of those. So if those are the endpoints, it turns out that the midpoint, so cut that in half. If this is at pi, half of pi is, well, pi over 2, literally half of pi in this case. You cut that in half, and sine wave will also be on the midline of that. So that's pretty simple. For sine, you've got 3 points that are all on that midline. The first point, the middle point, and the final point. Now we need to do the quarters or the fourths. So each of those 2 halves, I'm going to cut them in half one more time. So I'm looking in between 0 and pi over 2, and I know that exactly halfway between these, it has to reach its maximum. Luckily, I've got a little guideline for that, right? I drew that where y equals 2. So I'm going to cut it in half again. Well, half of pi over 2 would be pi over 4. And I know that it's going to have a maximum there. And so I put a dot up at the top. I'm going to do something similar for the back half of the wave, starting at the halfway point and going to the end. So between pi over 2 and pi, cut that in half. And I know that the sine wave has to be at its minimum at that point. So I look halfway between pi over 2 and pi. That would be 3 pi over 4. And I'm going to plot another point at the minimum, on that minimum guideline. So if you'll notice, I've got 5 points now drawn. And we can now connect the dots, essentially, where I can draw in starting at the y-axis. We go up to the max, back to the midline, down to the minimum, and up to the midline again. You'll notice that each time I drew a new point, with the current scale on this axis, each vertical line, each x interval, each point was exactly 1/4 of pi. And so each one of those was a new point. So if I wanted to keep on drawing this line, I could continue that pattern from the midline. I go up to the max, down to the midline, to the minimum, back to the midline, up to the max, midline, and that pattern will just continue over and over and over again. Midline, max, midline, min. Midline, max, midline, min. And you see it just continues up and down and up and down. And so you plot those first 5 points, get that single wave in. I know this was weird because I already had the graph drawn for you, but I wanted to help you kind of visualize it, all these 4 different properties of it that we're going to use to help us graph this line. All right. But how do you determine these from the equation itself? So on the right there, I've got that general form of an equation. If you want underneath this, you can also write sine, because it could be either sine or cosine. We're going to be graphing both of them. But your A, B, and C, they're going to be the same regardless of the type of trig function we're graphing. The thing you want to start with is going to be C. Whatever's being added or subtracted from your equation, that is the midline. So pretty straightforward. Look at the one part that doesn't have the trig function in it, that doesn't have sine or cosine, and that's your midline. So go ahead on your graph, you're going to draw a dashed line at that point, and that's going to represent the middle of your graph, of your wave, okay? From the middle of the wave, we need to then determine how high and how low is this going to go, the max and the min. To figure that out, you just look at the coefficient in front of the sine or the cosine. You look at the number in front, that's your amplitude, and that number tells you how high above the midline the wave is going to go, or how far below the midline your wave is going to go. And so starting from the midline, right, starting from C to find the max, you're going to add A, or starting from the midline, you're going to subtract A to get the minimum. Right, so whatever that amplitude is, just add it or subtract it from C, because that's the midline. That'll tell you how high is my graph going to go and how low is it going to go. Right off the bat, that is extremely simple. There's no calculations needed. I'm sorry, you're adding and subtracting, but I'm pretty sure you're all amazing at adding and subtracting at this point in your lives, right? All right, well, you can use a calculator if you do get something tricky like 3 plus 1, all right? He's so happy. The one calculation you will have to do, though, is to find the period, that single wavelength. Because remember, in your equation, you're not given the period, you're given something called the frequency, which is how often that wave occurs, or how many complete wave patterns there are in between 0 and 2 pi, or between 0 and 360. And so you have a simple calculation. You'll notice that this is the same way that we calculated the frequency, is the same way you calculate the period. You take 2 pi and you divide it by whatever this number is, b. That coefficient, that number inside the parentheses, that's not the x, right? Not the variable. And if it's in radians, we use 2 pi and we divide it by whatever that number is, whatever that coefficient of the variable is. If you see on your graph it's written in degrees, well then just start with 360, because isn't 2 pi the same as 360, everybody? Right? It's just a different unit for angles. And so then you would take 360 degrees and divide it by that number. Again, this is going to be determined based on the units on your graph. I want you to be able to use both of them, radians and degrees. So this is how you calculate each of these parts. Again, these three right here, you got that. That's a piece of cake. You really don't have to do any calculation. That's just practically given to you in the equation, right? The only thing you have to do is the period here, but luckily you'll notice it's the same way that you calculated the frequency. After you identified the wavelength, then you took 2 pi and you divided it by that wavelength to get the frequency. Well, working backwards, you do the exact same calculation. All right. So let's try putting this together. I've got 2 examples. I'm going to work with you, and then I've got a whole bunch of practice problems for you to try on your own. Or with a partner. Do you like how giant these graphs are that I gave you in your notes? For you to plot it out? I was hoping that it would work out better for you. So example 1. We need to graph this function, f of x equals 3 sine of 2x minus 1. All right, we have to graph this somehow. And on the left side, I actually kind of I guided you. I'm showing you, identify all 4 of these properties first to help guide you to draw your wave. You don't just want to go to the graph and just start like drawing willy-nilly waves, right? That's obviously not the correct graph for this. So first, the midline. The midline was C. To find this midline, you simply look at whatever's being added or subtracted. In this case, there's a -1 at the end of our function. That tells us where the midline is. Y equals -1. So you look at what's being added or subtracted to your function. You're going to go to that number on the y-axis on your graph, and you're going to draw a horizontal dashed line because it's not actually part of your graph. It's just like a guideline for us. Go to -1 on the y-axis, and go ahead and draw a dashed line there. Because that's our midline. That is the middle of the wave at -1. Next is we need to determine how tall our wave is going to be. What's the maximum and what's the minimum? Now I gave you a little formula to calculate that, but essentially you look at the coefficient in front of the sine or the cosine. It's a 3 in this case. Just move 3 units above and 3 units below that midline that you already drew. Super simple. So if you're at -1, okay, just count up 1, 2, 3. That's up at +2. That's going to be our ceiling. We're going to make sure that our wave does not go above that point. So that's at y equals 2. But the amplitude is also how far below the midline the wave is going to travel, right, for the trough. So starting at that midline again at -1, again, start on the y-axis, and just count down 3 units, right, whatever the amplitude is. You're going to move that many units down from the midline. I'm at -1. Go down -2, -3, -4. And this is kind of like the floor or the bottom of our wave. Now, before you do anything else, just take a quick gander at your graph. And does it look like the midline is perfectly in the middle of your max line and your min line? Does mine look like that?
No, mine doesn't.
Oh, okay. Yours is better than mine. That's good. It's impressive. It's good to have little victories in life. So just do a quick visual check to make sure that it's not like that you went the same distance above and below. So here, this is at y equals -4. You don't need to identify these lines. You don't need to write out y equals 2 and y equals -4. I'm just putting it there to help guide you. Typically, I would just go to the graph itself and just count 3 above and 3 below and draw in those 2 guidelines for the maximum and the minimum, because that's going to be where the tops of the waves and the bottom of the waves are going to hit. But now, I need to know how wide is my wave going to be. Is it going to be a skinny, narrow wave or a really long, wide wave? And that's going to be determined by the period. So this is where you take a look at the value that's written in the parentheses with the x or the theta or whatever our variable is. That's a 2. So go down here for the period, and to calculate this wavelength, you take either 2 pi or 360 degrees and divide it by that coefficient, by b. What number should I use for this function? Should I use 2 pi or 360 degrees? What do you think, everybody? Look at the units here. See how those are all in radians? They all have pi in them. So we want to use the 2 pi to divide it. That's going to be what tells us how we want to graph this. So I'm going to start with 2 pi and divide it by that coefficient, which was 2, right? Because it says 2x. So you divide it by 2, and then simplify that fraction, and we get 1 pi. So that tells us how long our wave is going to be. This is a sine wave. So where do we start? At the midline or at the max for a sine wave? Midline, good. So we want to start at the midline. So I'm going to go to that dashed line in the middle on the y-axis. The second point I want to plot is at whatever the period is for this wave. I've got a period of pi, so on the midline, I'm going to go to pi. because that's the length of a single wave, a single cycle. For a sine wave, then I want to cut that in half. And I'm going to put another point on the midline. So I just kind of visualize it. If I cut this in half, 0 and pi, half of that is just pi over 2. Now, break this into fourths, into quarters, right? Cut each half in half one last time. And that's going to be our maximum or minimum. For a sine wave, though, everyone, for sine, will it hit its maximum first, or does it go down to its minimum first? It's maximum. If you ever forget, think about the unit circle. If you start at 0 and you go up to 90 degrees, isn't that positive 1 if you go straight up? So sine starts at positive 1. And so then I'm going to go to pi over 4, and I'm going all the way up to my maximum, right? I would go up 1 unit, but because the amplitude is 3, it's 3 times that amount. That means halfway in like the second half of my wave, between pi over 2 and pi, I'm going to hit my minimum. So I'm going to put a dot down there at 3 pi over 4. At this point, you should have 5 dots on your graph. Now here's probably the most difficult part of graphing these. You want to connect the dots, but don't make mountains. Every year I see students graph their waves like this. Is that what a sine wave looks like?
No.
Not really. No, it's not. I also sometimes see students do squares. All right. Also, not the actual shape of it. So this takes a little bit of skill, a little bit of artistry. You want to try to make it flow like an actual curve. Make it kind of curve up, back down. Think of like a roller coaster, and end it there to get a nice smooth sine wave, rolling just like the waves on the ocean. Now that's just one cycle of our wave. We want to keep it going after that. So from here, do another wavelength. So go over 1/4 of pi, and you're going to hit maximum, then down to the midline. The next one will be down at the minimum. So go ahead and just continue drawing your wave to the edge of the graph. You can draw it in both directions if you want. So it would continue to the left as well, right into the negative numbers, because it goes both directions. All right, that's your sine wave. Pretty great, right?
Yeah.
So simple. Are you feeling okay with sine? All right, let's try a cosine wave next. Dun, 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 dun. Example 2. So we're going to do the same process as you did with that sine wave. We're going to identify the same properties, put in all our guidelines, and then plot our 5 points, and then just connect the dots. We want to start with the midline. Who can tell me what the midline is of this function? How do you know it's 2? Yeah, just look at what's being added or subtracted. That is your midline. It's at y equals positive 2. So on the graph, go to positive 2, and let's draw this dashed line. That's our first guideline. It's going to run right through the middle of our wave. Next, we need to determine the maximum and the minimum. That's going to be based off the amplitude. What's the amplitude of this function, though? Yeah. Normally, it's the number written in front of like the sine or the cosine, but is there a number there? Like right here is where the amplitude would be written, but there's nothing there. So what number do we use? We use 1, right? There's an invisible 1 in front of that cosine. So the amplitude is 1. So on my graph, pretty straightforward. All I'm going to do, starting at that midline, okay, so starting here at 2, I'm going to move 1 unit above it to get to my max, which will be at 3. And we're going to draw our max guideline at 3. Again, you don't have to write what these lines are on the left. I'm just putting it there just for reference for you. And then starting at that same midline, move that exact same distance down to get the minimum line. So from the 2, I'm going to go down to 1. And that's our min. So you can see this is going to be a pretty short wave, right? It's going to be kind of squished down in that small space. Going to bounce back and forth in between those 2 blue lines. This is at 1. Last, the period. This one we have to do a little more calculation, but it's nothing too crazy advanced. We look inside the parentheses, and it's the coefficient of x, the number in front of it. But wait, there isn't anything in front of that x, is there? There's something below the x, but not in front of it. So whenever you've got a fraction like this, x over 4, you want to think of that as 1/4 times x. So you take that denominator, you imagine there's like an invisible 1 in front of the x, and you're going to bring that fraction out in front of the x to make that your coefficient. Because dividing by 4 is the same thing as multiplying by 1/4. Right? If I take 1/4 of 100, I get 25. If I take 100 divided by 4, I also get 25. So we're going to use 1/4 as b. That's the frequency. Now to calculate the period, we take the units 2 pi, or 360 degrees, and we divide it by that number. But I don't have any units on my x-axis. Eek! If not there, you can just treat each one of those as like 1/4 of 2 pi or 360 or whatever you have. Basically, you can scale it however you want. For me, I think it's easiest to make each one of those 1/4 of your wavelength. So let's calculate this period. Let's use degrees on this one instead of radians. So if it were 360 degrees, you divide it by 1/4. All right, let's do a little bit of fancy math here. Because I've got 360, but I'm dividing it by 1/4. I'm dividing by a fraction, which is the same as multiplying by what? The reciprocal, good. What's the reciprocal of 1/4? Just 4. So this is the same as 360 degrees times 4 over 1. All right, what's 360 times 4? Good, 1440. 1,440 degrees. This is going to be a really long wave. That means it's not going to complete a full cycle until it gets to 1,440 degrees. That's really, really wide. It's going to be a low wave. So if I ever have a blank axis like this, what I'm going to do is just to make it easy for me to graph. Remember how I plot those like 5 points to draw my graph? What I'm going to do is I'm going to count out 4 spots and make that this period length. So I'm going to count out 1, 2, 3, 4. And I'm going to make this that 1440. Because I'm going to make that the end of my wave so I can fit all 5 of those points in between. Is that what you did? Oh my gosh, spot on. Did you tell him to do that? Oh my gosh. Look at this, you're actually nice today. It's really positive. I support that. So let's go back up to our wave and let's try actually graphing this. So I've got my 3 guidelines. I know that the wave has to end right here at 1440 because that's the period, that's the length of a single wave cycle. But now, what type of a wave do we have this time? Cosine. All right, this is a cosine wave. Does cosine start on the midline or on the max? Cosine starts up at the maximum. If you think about on the unit circle, if we started at 0 degrees or 0 pi right up to the right, cosine has a value of 1 here because the coordinates, if I just go to the right 1 unit, is 1 comma 0. And cosine is the x coordinate. So cosine starts at 1. In this case, it's going to be whatever the maximum is because we shifted it and the amplitude is 1. So to graph this, I'm going to start on the y-axis. That's always going to be our starting point on the y-axis, up at the maximum, which happens to be 3 in this case. Now, that 1440 is the end. Where will the end of my cosine wave occur? At the maximum, at the midline, or at the minimum? Where should a cosine wave end? If it did end at the minimum, if it were to start again, it had to get up to the top somehow. A nice way to remember this, everybody, is wherever you start your wave, it's got to end at that same spot so that it can begin the next cycle. And so, like, since I know cosine starts at the maximum, it would have to end at the maximum so it could continue that next cycle all over again. So then I'm going to go to 1440, put a dot right up there at the max as well. Now, halfway between those two, where will the graph be? For cosine, remember it kind of makes like a bowl shape or a U shape in a way. So cut that in half, and it's going to be at the minimum, right down here. That'd be at 720, if you want to write that down on there. Now cut each of those in half again. We want to look at the quarter and the 3/4. Where will the cosine wave be at those points? The midline, right? It starts at the max, goes to the midline, then down to the minimum. You can just think, if it's at the max at 0, then it's at the minimum here, halfway in between that, well, it's got to go past this midline somehow. Same thing right there. If you want to put in values, this would be 360, and this is 1080. And so you see how the cosine starts at the max, goes to the midline, then the minimum, then the midline, then the maximum again. Then it can just repeat that pattern over and over and over again. Now the tricky part. The way I've got my dots written, doesn't it look like a V, like a letter V, pretty much? You kind of want to draw straight lines, but should we do straight lines? No, we got to curve it. This is a little tricky. Curve down and up like that. Go ahead and try to draw that in. Connect your dots to make it look like this curve pattern. You have curves?
I got curves.
Oh, that's nice. That's nice. You can continue the pattern. I'm going to go forth one more line. It's going to be at the midline. One more will be at the minimum. So if you want to continue this wave from here, it's going to curve down. Continue that shape. Same thing over here. It's going to curve. Keep on going to the left forever and to the right forever. I would like you to draw the wave out all the way to the edges. Don't just draw one cycle. I want you to draw it all the way to the edges of the graph, because these do go on forever. Do you think if you practice this a couple times, it'll help? Yes. Do you think you're capable of doing this on your own? right? Like, do you feel like you could do this some more, this class? Yep, it's good. Just identify those guidelines and then just plot the points. Any questions on these two examples before I release you? All right, so let me show you what your practice for the rest of class is going to be. And so this first page is just identifying those properties, like the amplitude and the period. You're just going to pull those off of the equation because you need to identify those in order to graph it. You need to know what those values are in order to make it work. I didn't put the midline on here because hopefully you all can easily just identify a plus sign or a minus sign and a number after it. I'm trusting that you're all more than capable of doing that for the midline. Think you can do that?
I think so.
All right, these ones at the top, just quick note. These first ones, I want you to find basically the period in degrees. Okay, it says degrees. For the bottom four, I want you to find the period in radians. Okay, so instead of using 360 degrees, you'd use 2 pi. The second page, now you're actually putting it together. You're going to identify those properties and you're going to graph them. Okay, so find the midline, the max, the min, determine the period. How long is that single wave cycle going to be? And plot those different points, right? You've got 5 points to plot for either a sine wave or for a cosine wave. Just remember where each of them start and where they end. And then draw in your curve. All right, this second page, if you look at the x-axes, these are all in degrees. Your third page, you'll notice these are all in radians, all right, to kind of keep it separate for you so you know what to focus on. But still the same idea, the same concept. You've got some sine waves, you got some cosine waves, all right? I do have these answers posted for you to double check, and you've got 45 minutes now to practice these to get it done. I'm also going to come around to bring your test for you to look at, see if you have any questions. You can make some corrections on them. Everyone at home, just go ahead and you can grab this worksheet online on my calendar. Keep on working. If you do have questions, give me a shout out. I'll still be listening. I'll hear you. And good luck, all right?